Okay, midway through a question, where at the moment we're at this line here. We want to somehow use this property here that was given in the question, and we want to eventually get to this here. So the question is, how do we use the property given and get to the answer we require? Well, first thing is I don't like the fact this is greater than or equal to, and this is a less than or equal to. So I would like to write this with a greater than or equal to, so I'm going to switch sides. And I want a 4 there, so I'm going to split this into 4 plus 4, and maybe you can see what I'm going to do. Okay, so that's 4 plus 4. Okay, and then what I'm going to do is that 4 is greater than or equal to this. So I can take one of those 4's and replace it with a to the power of 4 plus b to the power of 4 plus c to the power of 4 plus d to the power of 4. I'm essentially saying that this is greater than this, which is greater than or equal to 4 plus this. Okay, but rather than writing it horizontally, I'm going to do it vertically. Okay, so if you want, and you can put an equal sign on this one and then a greater than or equal to when you apply this one. Okay, 4 plus a to the 4 plus b to the 4 plus c to the 4 plus d to the 4. Okay, and then you would quote as you know, this given, something like that. Okay, and then hopefully what you can see is that you can minus a to the 4, b to the 4, c to the 4, d to the 4, and by minusing on both sides you can cancel all these guys out, and you'll be left with the required result. Alright, that was a bit tricky. Another tricky one now coming up. Let's go. Okay. Usually the beginning of these aren't too bad. It's towards the end that they get a bit tricky. Prove that this, where this is greater than 0. Well, I'm going to try my little trick of minus and root that, and all square. And if I'm doing that, I need to say that I need to use this fact that a, b, x, and y are greater than 0 so that these square roots exist. Expanding a y minus 2 square root a, b, x, y plus, that'll be bx greater than or equal to 0. Yes, we've got the result. Okay, that's a done. B. Show that the sum of that and that is that. Okay, that's just a bit of algebra. Okay, I'm looking 4 terms. I'm thinking grouping in pairs, but I might just shift this guy out the front there so you can see nice factorization going on. So take out an A, take out a B. I'll just put it the order they put it. Okay, now they wouldn't get me to do that for nothing, so that's obviously going to be important for part C. Now, one thing I've just noticed about part C is that they've got greater than or equal to instead of less than or equal to. This should be written in reverse. Okay, poor question. Now, when there are 2 inequality signs, there's 2 things I need to prove. I need to prove this is greater than or equal to this, and I need to prove this is greater than or equal to this. So I've got 2 things to prove for part C. Okay, so I'm looking at part A. Part A, this is the same as this. And maybe I can write a similar result for the other bracket and then multiply. That's what I'm thinking. That would prove number 2, I believe. This guy, I reckon's got something to do with part B. So I reckon I'm going to use part A for number 2 and part B for number 1. Let's do number 2 first. I think that. So from ay plus bx greater than or equal to 2 square root abxy. Similarly, if I want to get this, all I'm doing is I'm switching the x and the... Yeah, I'm just switching. Similarly, I can write ax plus by is greater than or equal to 2. It'll still be the same because all I've done is I've switched x and y. Now I'm going to just rewrite this so it matches the bracket order there. Okay, now because this is greater than 0 and greater than 0, we're allowed to multiply. Remember, if every part is greater than 0, you can multiply the parts together and inequality sign stays the same. Multiplying, I like before I multiply, I like putting like a greater than 0 where it belongs. Okay, where it belongs. We'll get exactly what they want. Greater than or equal to, that'll be 4, and square root that, it's going to be abxy. So that's number 2 proved. Looks like number 1 will be the tricky thing to prove. Okay, so I can see a quarter this guy squared, and I'm going to change it to the sum of this and this. Okay, now a very useful trick for dealing with this crazy, all this crazy stuff in the brackets is I'm gonna let A be this guy and B be this guy. I'll do that down here for number 1. So before I do that, I might quickly just connect it to part B. So I'm going to do that first. Because this product is equal to the sum of these two, okay? So, and I'm going to do a consider left-hand side minus right-hand side as well, because I don't know how to proceed otherwise. Alright, so this is going to be the sum. So it's going to be the sum all squared. So it's going to be ax plus by plus bx plus ay all squared. That's from part B. And now I'm going to let, just to make the algebra significantly easier, a be ax plus by and b equal to bx plus ay. Okay. So this now equals to, right left hand side minus right hand side, equals to 1/4, that's a plus b all squared, minus AB. Okay, now I want to show, if I'm doing left hand side minus right hand side, I want to show that's a greater than or equal to. So I want to show that it's greater than or equal to 0. So I need to show this guy is greater than or equal to 0. Okay, let's make a common denominator of 4. And this looks very familiar. Expand. Okay, collect like terms there. And then you got a perfect square. Okay, so that's going to be a minus b all squared on 4, which is going to be greater than or equal to 0. Okay, so well, therefore we've proven number 2. I'm not going to write everything. 2 is proven. Since 1 and 2 is true, the result is true. Something like that. If I had more time in the exam, I would write down what I've just proven, but I want to move on. You should be able to do the first 10 questions of 2.3. If you are struggling, only if you're struggling, Cambridge 2D is a little bit more scaffolded. So you can, if you want some more scaffolding, some more support, look at Cambridge 2D. Okay, everyone's nightmare, the AMGM. These questions can be crazy. And it's crazy because you don't know how far to go. So we'll talk firstly what arithmetic mean and geometric mean mean. And the arithmetic mean is always greater than or equal to the geometric mean. So the arithmetic mean is your usual mean that you're used to. Add up all the numbers, divide by how many numbers there are. The geometric mean is the nth root of the product of n numbers, okay? So if there are 2 numbers, it would be the square root of the product. If there are 3 numbers, it would be the cube root of the product, and so forth. Okay, the inequality holds true if the numbers are equal. So if the 2 numbers here, x and y, are the 2 numbers in this example, if they're equal. Okay, this is the AMGM for 2 numbers, okay, but you can also extend this to more than 2 numbers, and I've written it down below. The proof for the 2-number AMGM is very simple. You start off with square root x minus square root y all squared, and that's basically changing that plus to a minus square root all square. Expand and quote, oh, by the way, something important is that it only applies for positive. The numbers have to be positive. Okay. I believe they can equal 0 as well. Okay, but yeah, usually positive is what they give. Okay, expand and then you move across, and then you get the required answer pretty quick. That proof you should memorize. They often ask you to do a quick proof in part I for a 1 marker, and then they get you to use it in part II and so forth. So if there are n positive, on all n numbers are positive, then the arithmetic mean, or the normal mean, adding up all the numbers, dividing by the numbers, is greater than or equal to the geometric mean, the nth root of multiplying all n numbers. The equality happens when all n numbers are equal. Proof of the AM greater than GM for n equal 3, n equal 4 in the general case should be known. We'll do that later, okay? Often HSC questions guide you to use AM greater than or equal to GM by quoting it in the question. It's very often that they'll give you the result in the question and you'll need to sub in, or they'll get you to prove it in part I and then use it in part II. Another clue that you might use AM greater than or equal to GM if it says that all the numbers are positive, okay? For positive reals, use AM greater than or equal to GM. Usually in the exam it'll actually give you something like this, okay? To prove this. Okay, so the 2 numbers appear to be A on B and B on A. Okay, if you want, I'll put over 2 greater than or equal to square root and then the product. Okay, because there's 2 numbers we've taken the square root. Yeah, you just multiply by 2 and this guy cancels and that becomes square root of 1, which is 1. Okay, so we get the required result. A plus B on A is greater than or equal to 2, where A and B are positive.